Assalamualaikum and a very good morning to Dr. Aizuddin and beloved student. We are from Group 1 and today we'll be presenting about Experiment 1 which is Marcet boiler. The introduction for Marcet boiler. The heat initially causes water molecules to evaporate. This causes the pressure in the steam chamber and thus in the water to rise. As the stream pressure rises, the boiling point temperature also increases. This is because the water molecules encounter increased resistance as they attempt to move from liquid to gas form. Consequently, each steam pressure has an accompanying precisely defined boiling point temperature. The objective of this experiment is to observe the relationship between the pressure and temperature for the saturated stream. The result obtained from this experiment will be compared to the saturated and steam table given. A graph will be obtained using the values that is obtained from the reading of the Marcet boiler. The theory of Marcet's boiler experiment is thermodynamic properties of a pure substance could be determined by two of the following characteristics, which is T, P, H, S, and V. Data characteristic could be obtained either from the experiment or equations or using certain among two thermodynamic properties that easily measured are temperature and pressure. Relations between these properties could be expressed in the form of graph or equation. And the equation is dt over dp is equal to T in bracket of Vg minus Vf over Hf minus Hg, where Vf is equal to volume of water, Vg equal to volume of steam, Hf is equal to enthalpy of water, Hg is equal to enthalpy of steam, and Hfg is equal to heat dormant of vaporization. Carry on with the theory. An ideal gas can be characterized by three states of variables. The number one is absolute pressure, number two is volume, and number three is absolute temperature. The relationship between them may be derived from kinetic theory and is called the ideal gas law. As the energy in the water rises, more molecules may leave the surface as a result of increased molecular activity, which continues until the equilibrium condition is obtained. The pressure differential between the steam and water surface determines the equilibrium condition. Lower pressure makes it easier for molecules to escape the water surface and uses less energy to reach the boiling point. The temperature at which equilibrium occurs at a specific level is called saturated temperature.
Okay, so this one is the experimental setup. So I will talk about the labeling of the Marcet boiler. First one is the green valve. The green valve is to drain the vessels. Secondly is the heater. Heater is to heat the distilled water. Then the third one is overflow valve. Overflow valve is to ensure the vessels is filled to the correct level. Then filter plug is to pour water into the boiler. The next one is safety valve is to prevent excess pressure built up in the boiler. Then temperature sensor is to measure the boiler temperature. And the seventh one is manometer. The eighth one is boiler with insulating jacket. The 9 temperature gauge, 10 heater switch, and the last one 11 is the master switch. This one is the apparatus. The apparatus consists of spanner and Marcet boiler. So Marcet boiler consists of, for the previous slide I already talked about, is the same, and the spanner is actually is open the filter plug so can put the water inside the Marcet boiler. So this one is the overall methodology, and for the next slide I will talk about this methodology also, and together the video that we did our experiment last week. After the overflow valve and the filter plug was opened, the water was filled in the Marcet boiler until water overflowed through the overflow valve. Then, the filter plug was closed and tightened it using the spanner. Next, The main switch and the green heater switch were turned on. The overflow valve was closed once the temperature reached 97 degrees Celsius. The overflow valve, the temperature for each increment of 0.5 bar was recorded in the table 1 until the pressure reached 3 bar. The heater switch was turned off and the temperature for each decreasing of 0.5 bar was recorded in the table 1. So this is the safety procedures and precaution. For the safety procedures, firstly, make sure to wear gloves while closing the overflow valve when it is heated. Secondly, close the main switch manually if the temperature is reaching to 200 degrees Celsius. Third one is avoid direct contact with the body of Marcet boiler when the temperature is high. The last one, use spanner correctly to loosen the grip of the filter plug. Precaution. Firstly, eyes must be perpendicular to the reading scale of manometer when observing the changes of pressure. Secondly, close the overflowing valve directly when the temperature reaches 97 degrees Celsius to avoid the loss of heat.
Okay, now we move into the result section. In this section, we have the table 1, result of experiment. In this table, we have first column, gauge pressure in bar, second column, absolute pressure in bar, the third column, steam temperature in degrees Celsius, and we have divided it into the 3 sections. The first section is increasing pressure, the second section is decreasing pressure, and the last section is mean. In the fourth column, we have measured slope, dt delta t over delta p. And the last column, we have calculated slope, tv over hfg. Next, we move into the calculation part. In this experiment, we have 5 calculations. The first calculation is calculation of absolute pressure. To calculate the absolute pressure, the formula is pressure absolute equal to pressure gauge plus pressure ATM. In this example, we have 0.5 bar plus 1.0 bar is equal to 1.5 bar pressure absolute. Next, we have the calculation of mean temperature. To calculate the mean temperature, we use the formula temperature average equal to temperature increase plus temperature decrease over 2. So in this example, we have 107.2 plus 110.1 over 2, and we have 108.65 degrees Celsius. The next calculation is calculation of delta P. Calculation of delta P, we can use the formula of delta P at 2.0 bar equal to pressure at 2.0 bar plus, minus pressure at 1.5 bar in absolute pressure. So in the example, we have 2.0 bar minus 1.5 bar equal to 0.5 bar, or it is equivalent to 50 kilopascal. Next, we have the calculation of delta T. To calculate the delta T, we use the formula of delta T at 2.0 bar equal to temperature at 2.0 bar minus temperature at 1.5 bar, also in absolute pressure. In the example, we have 118.05 plus 273 to convert it into the Kelvin minus 108.65 plus 273 also convert it into the Kelvin, we get 9.4 Kelvin. The last calculation is calculation of measured slope. To calculate the measured slope, we use the formula of delta T over delta P at 2.0 bar absolute pressure equal to delta T at 2.0 bar absolute pressure over the delta P at 2.0 bar absolute pressure, and in the example we have 9.4 Kelvin over 50 kilopascal, and we got the 0.188 Kelvin over kilopascal. Next, we move into the graph. In this slide, you can see the graph 1, the absolute pressure bar versus temperature degree Celsius for heating process. In this graph, we can tell that the data obtained from graph 1, absolute pressure increase as temperature increase. Next, we go to the graph 2, absolute pressure bar versus temperature degree Celsius for cooling process. In this graph, we can tell that during the cooling process, temperature still increase even heating switch was turned off. The observation from the graph is that temperature decreased as pressure. This is due to temperature and pressure which is dependent on each other. And next, we have the last section in the result is percentage error. In this slide, we have put a table that have two columns. The first column is measured slope, delta T over delta P, and the second column is calculated slope, TV over HFG. To calculate the percentage of error, we use the formula of percentage of error equal to measured slope minus calculated slope over measured slope. In this example, we take 0.188 minus 0.0483 over 0.188 and times with 100% to convert it into the percentage. So in this experiment, our percentage of error, we got 74.31%. And as you all know that in the experiment, the percentage of error shouldn't be more than 20%, but in our experiment we got 74.31%.
So this is the discussion that have been done for this experiment. This is the observation during the experimental and observation from the graph. This experiment is to observe the relationship between the pressure and the temperature for the saturated steam. Before we conduct the experiment, the pressure is at 0 bar and the temperature of water is in room temperature. As the pressure increase, the temperature also increase. This is due to the pressure and the temperature depend on each other. Water flow from overflow valve. The overflow valve was opened to allow steam escape through during the boiling process of water. From the both graph, the steepness of both graph are almost the same. This implies that the rate of changing of temperature to the pressure is almost the same for both heating and cooling process. But cooling process needed more time compared to heating process. This is the questions and answer that we got from the experiment. First, what is the use of vapor that produced by the Marcet boiler? Vapor can be used in energy steam turbine. Steam turbine is a machine that extracts thermal energy from pressurized steam and use it to work on rotating output shaft. Second, why we use distilled water in the experiment? We use distilled water because distilled water prevents any corrosion in the vessel and any impurities. Why cooling process needed more time compared to heating process? This is due to no external causes to help the heat to move out from water molecule as compared to during heating process where there is external reason which is the boiler to help increase the temperature faster. And these are the conclusion that we've done after we did the experiment. In the experiment, it shows that the relationship of table and theory of temperature and pressure is directly proportional in balance with water. By comparing the graph and data accumulated, we can find the percentage error using formula. Although the percentage error is high, which is 74.31%, we can improve the result of the experiment with performing it at room temperature by switching off all the fans and also by repeating the experiment and taking the average value. If some insulation were kept on the Marcet boiler to reduce heat loss, the experiment could be more accurate and precise. And lastly, the improvement for the experiment. First, safety features.
emphasizing the importance of safety such as overpressure protection, temperature sensors, and emergency shut-off system. This ensures the safety of students and minimize the risk of accidents. Second, pressure control. Implement a system for precise pressure control. This can allow students to explore the effects of changing pressure on the boiling point, emphasizing the relationship between pressure and temperature. And lastly, educational materials. This is to provide various type of educational materials, including experiment manuals, videos, and simulation to support students' understanding of the experiment and its correlation.